Hello and welcome to our channel. I'm Vanessa from MS Control Group and today we are introducing the BIXCS-1400, a Linux-based modular control system for infrastructure and industry by MS Control. Let's get started. BIXCS-1400 already offers numerous interfaces on board and provides both beginners and professionals with an easy entry into the world of open automation systems. The BIXCS is a compact device with dimensions of 112 by 84 by 25 mm, housed in a powder-coated aluminum case with a wide-range DC 24-volt power input. It is perfectly suited for continuous 24/7 operation in any environment. The device can be delivered in different temperature classes and depending on the model, it is suitable for operation between -40 and +80 degrees. It supports a supply voltage between 8 and 36 volts with connection options via lockable twist lock plugs or screw terminals. The MTTF is over 200,000 operating hours and the device comes with a 5-year bringing warranty. All device variants offer two LAN ports, 1 gigabit LAN for IT networks and one 100 megabit LAN for OT networks. In addition, there are 3 USB ports, a console connection for Linux remote access, and the software switchable serial RS-232/RS-485 interface. The BIXCS-1400 can be expanded with optional modules like Wi-Fi, Bluetooth, LTE modem with GPS, a Hirscher Fieldbus card, as well as a multi-I/O board with up to 4 slots for CAN, RS-232, RS-485, and I/O modules. This allows the device to be perfectly configured to meet specific requirements straight from the factory. This picture shows the internal slots for the extensions. An internal SIM slot is available for LTE modules and up to 4 antennas can be connected via SMA connectors, 1 Wi-Fi, 1 Bluetooth, 1 LTE, and 1 GPS. The BIXCS comes with a network architecture suitable for many applications. The LAN 1 interface is configured as a DHCP client for connections to an IT network. The LAN 2 interface is set up as a DHCP server for connecting other local Ethernet devices. A computer with the BIXCS board branch can be connected via LAN 1 or LAN 2. For file-bus communication, the system supports Modbus TCP on LAN 2 and Modbus RTU on the serial interface, both available as master or slave. From the factory, the BIXCS starts with a simple ready-to-use configuration. The LAN 1 port is set as a DHCP client and receives its IP address from a DHCP server in the external IT network. The LAN 2 port acts as a DHCP server with the IP address 192.168.252.1. The serial interface is pre-configured as RS-485 with Modbus master address 1 and is ready for operation. The BIXCS offers 4 independent virtual PLCs in the standard configuration, which are executed in parallel as real-time Linux processes. All PLCs can be assigned to available network interfaces. Externally, these PLCs are addressable via port addresses from 1100 to 1400. Internally, the PLCs can exchange data via the loopback interface and the T5, UDP, TCP/IP, and Modbus TCP protocols. The integrated web server runs on Python under Linux Debian. It provides direct browser access to BIXCS configuration as well as monitoring and control of PLC instances. Updates and maintenance are also carried out via this interface quickly and without additional software. In addition, simple user and human-machine interface applications can be programmed and integrated using the Python Flash framework. BIXCS can be flexibly extended via Docker and Node-RED and supplemented with additional Linux applications. The integrated PLCs communicate via Modbus or shared memory, ideal for customized knowledge-based solutions. In the next part, we briefly show how easy it is to get started with programming using Straton Workbench and the BIXCS-1400. After starting Straton Workbench, we find ourselves on the editor's start page. Here, in the center, we can see the section Tutorial and Recent Projects, on the right, Helpful Tips, and at the top left, the main menu. Through the File menu, we can open projects, add them, or create new ones. With New Project List, a new empty project list is created. This is useful when working with multiple projects in a shared environment. With Open Project List, we can open an existing project list, for example, from local storage or from a zip file. Under Add Existing Project, we can add an already existing project from the hard drive, from a zip file, or directly from the target device. And finally, we select Add New Project to create a new project, or we simply click Create a New Project on the Start page. Next, the Project Assistant opens. Here, we first define the storage location of the project. Under Destination folder, you can choose any path. By default, the project is saved in the Straton folder under Documents. In the Name field, we assign a project name, for example BIXCS-1, and in the Comment field, we can enter a short description. With Next, we proceed to the General Project Settings. At the top, we can see the Template field. Here you can select an existing project template or a predefined structure. For the introduction, we choose Empty Project to start with a completely empty configuration. Below that, we find the Options section with the project languages. Straton supports all standardized programming languages: function block diagram, ladder diagram, structured text, and sequential function chart. For this example, we choose function block diagram. The debug or release setting defines the project mode. In debug mode, the program can be loaded directly to the target device, tested, and monitored. We remain in debug mode so we can observe variables during development. In the configuration field, an alternative runtime environment can be selected, such as T52 Safe Runtime for safety-related applications. By default, the setting remains on default, which is sufficient for standard control applications. In the Communication section, we define how the workbench communicates with the target system. In Settings, we enter the device IP address and port. Below that, we select the standard T5 protocol. In the next step, the I/O configuration page opens. Here we add the communication interfaces we need in our project. For our project, we select Modbus Master. Finally, we activate the option Use Binding for real-time data exchange and click Finish. A Straton project is well structured and includes several main sections. At the top is the project name, in our example, BIXCS-1. Directly below is the folder Exception Programs. These programs are automatically executed by Straton runtime system when specific system events or runtime errors occur. They are defined using special directives. Startup is executed before the first program cycle begins. Shutdown runs after the final cycle when the runtime is stopped and can be used for saving data or cleanup. OnDiv 0 is triggered when a division by 0 occurs in the user program, and onBad index reacts to an invalid array index. Below that is the Programs folder. Here we create all logic programs that are executed on the controller. Right-clicking on programs allows us to create new programs or subfolders. The Shortcuts menu allows inserting links to other project sections. The next section is Watch, used for debugging. Here variables can be monitored and analyzed in real time, which is especially useful during testing. Under Initial Values, we define start values for variables that are loaded automatically when the system starts. Another important section is Fieldbus Communication. Here, we see all communication drivers that are active in the project, for example, the Modbus Master. Binding configuration shows the active communication connections, in our case, public with a port 9000. The Profile section contains predefined communication profiles provided by Straton or the device manufacturer. They are used to map variables to protocols or external systems. Under global defines, constants or system-wide definitions can be created, for example, fixed values for scaling or device IDs. The Variables section contains all variables used in the project. Straton distinguishes between global variables, retained variables, and local variables. Global variables are visible throughout the project. Retained variables keep their values after a restart, and local variables are only valid within a specific program. At the bottom, we find the Types folder. This includes unions, structures, enumerated data types, and bit fields. Enumerated types allow defining symbolic values such as for a traffic light controller. Bit fields allow naming individual bits for an integer value. Structures allow combining multiple elements into a complex dataset. Unions allow multiple data elements to share the same memory location. Next, we look at which libraries are included in our Straton project. To do this, we open Project, Settings, and select the Options section on the left. Here we can find general project settings such as cycle time, compiling mode, or online change. One important section is Libraries. With Edit, we open the list of all libraries currently active in the project. Using Add, we can include additional libraries or remove unused one with Remove. After that, we close the window with Close and confirm with OK. All necessary libraries are now loaded. In this section, we show how to import variables from BIXCS into Straton. First, we click on Global Variables. Then, we select Edit Variables as Text. In BIXCS, we previously created a simple table and saved the file as a CSV. We then import the rows from the BIXCS file directly into the text editor. After confirming with Save, Straton automatically imports all the variables and they immediately appear in the list of the global variables. Straton Workbench includes an integrated help system that contains all important information about programming, communication, and project configuration. By selecting Edit, Finding Files, we can perform a project-wide search. This allows us to scan all files, programs, comments, and source of code for specific terms. With replacing files, variables, or text blocks can even be replaced automatically across multiple files. Through the main menu Help, we can access all help sections at any time. On the left of Topics, we have a navigation panel that lets us jump to any section. The integrated search bar in the top left allows targeted searches, for example, Variable Editor. Using Search from the Help menu, we can also start a keyword search across the entire help system. This makes it easy to find commands, settings, or function blocks without scrolling through all the chapters. Another important section is Tutorials. Here, Straton provides a collection of PDF documents explaining typical application examples and best practices. Under About, we get information about the installed version of the Workbench, and with Language, we can change the display language of the user interface. Finally, we create an example project. We begin in the Variables section and create 3 global variables: Start, Safety, System Run, all of type bool. Next, we create a subprogram. Right-click Programs and select Insert New Item. We set the name, check signals, and confirm with OK. In the parameter window, we define the program interface. Under Inputs, we add two parameters, Start and Safety of type Ball. And under Outputs, we define OKOut of type Ball. We open check signals in the editor. Here we can add a function block by dragging and dropping it. If we click on it, we can choose which function to use. In our example, we use the AND function. Now we connect Start and Safety to the inputs and connect the output of the AND block to OKOut. Now we switch back to the main program. Here we drag and drop the subprogram check signals into the main program. We connect the subprogram parameters with the global variables. This way, main receives the evaluation directly from the subprogram. Next, we switch to the Fieldbus configuration. We click on Modbus Master and add an Ethernet connection via Insert Master port. Here we use the IP address of the device, 192.168.252.1 and port 1100. The next step, we create a read request with insert slave. We select read input bits, set the base address to 1, and set the number of items to 2. Then we assign the bits to our variables. For bit 1, we assign the variable start. And for bit 2, we assign the variable safety. Now we can compile the project and start the simulation. Afterwards, we change the input data to test the program flow. Then we right-click on Watch and select Insert New Item. Here we select the tabular model. Then we add with the drag and drop the variables Start, Safety, and System Run. Since we are not using a real Modbus connection, the values can be changed directly in the watch table to test and demonstrate the behavior. In run mode, we can manually observe how system run becomes true when both start and safety are set to true. Thank you very much for taking the time to watch this video. More exciting videos will follow soon, so stay tuned.